word I have seen all over the place called circumscription. You must have learnt it, right? I've also seen statements in the following. When I read textbooks, I see, things like this. If you have a circle like this, and if you have a triangle like this, the circle circumscribes the triangle. So this one, I'm going to say shape A, and this one, I'm going to say shape B. And so I want to know what circumscription is, and one way of knowing what circumscription is to define it. Okay? So again, it hasn't become one yet, so I will help you with part of the definition. Okay, I can write shape A circumscribes shape B. I'll write one more word, if and only if. Shape A, any shape A circumscribes any shape B, if and only if. Hold on. Everybody clear what to do? Give me a definition, complete this definition. Okay. Everybody ready? Okay. Who hasn't spoken at all? Whose voice haven't I heard? Have I heard everybody's voice? Correct. I'm not sure if I have heard everybody's voice, so I want the person who has spoken least to give me the definition. You have spoken least. Go ahead.
Shape A circumscribes shape B if shape B
if and only if.
If and only if shape B lies inside shape A.
Shape B
lies completely inside shape A.
Completely
inside shape A.
Inside
shape A.
Inside A.
And its vertices lie on shape A.
And the vertices of A lie on.
Vertices of B lie on.
Vertices of B
lie on A.
Lie on A. Okay. Somebody has proposed a definition, and your job, the other people's job, is to evaluate it, right? How do you evaluate it? Look for counterexamples. That's one. I'm not saying this is the only way of evaluation. One strategy is to look for counterexamples. Can you think of counterexamples?
Is it necessary that shape B has to be a triangle or a polygon?
I just said shape. So that's one, yeah.
If shape B is a circle and shape A is a triangle, then a circle doesn't have any vertices.
Okay, I am a slow learner. Draw this thing.
If shape B is a circle and shape A is a triangle, then a circle has no vertices.
Okay, so let's see.
So what else?
Wait. Do you, the picture that you drew, would you agree it's a case of circumscription? Yes or no?
Yes.
You don't think it is circumscription?
It is.
Inscription.
Yeah.
Well, there seems to be some difference of opinion because she's using a word I haven't heard before. Inscription. So it seems to me. Yeah. Go ahead. Yeah. Oh, sorry. Oh, you should erase it. Yeah. So here, this is shape A, right? And this is B. Yeah. So one thing I want to know is, since I don't know the word inscription, what I want to know is circumscription the reverse of inscription?
Yes. The inscription is Ashokan inscriptions are there in history.
Please talk to him. Explain to him. What is this? I'm getting confused. What?
Ashokan inscriptions are there in history. I have read them.
Inscriptions like
In a different
can be
sense.
defined, yeah, 2-3 meanings to that.
Inscriptions are letters inscribed,
Yeah,
and
And these are shapes.
inscribed in another.
actually they're the same.
Letters are also
They're
shapes.
the same thing.
Letters inscribed in stone.
That's three-dimensional inscription. This is two-dimensional.
Yeah, that's
Do
this side.
the definitions of history match the definitions of mathematics?
No.
Never.
So we have to.
So
Can we say that inscription in this is the same as inscription in that?
no? Then of course if you say that, there is this word inscription in history and there is a word inscription in mathematics,
Which means
They mean different.
they mean different things. So they are actually two different concepts. Just happens to have the same word,
Yeah.
right?
but they're not concept.
They have
Ah, here is the difficulty. So he's saying that they are completely different concepts, but she's saying they're not completely different. There is something. Okay? So if I understand you, this is what you're saying. There is some difference. Where do I draw this? So there is, let me say, inscription 1, which is that of history. Then there is inscription 2, which is that of math, or geometry to be specific.
Yeah.
And there is a difference between them. Right? That seems to be clear, or at least seems to be the case. But she's saying it is not that they're not completely different. They also have some similarity. So there is another inscription, a sort of general notion of inscription.
English from English.
Whatever it is like saying take chimpanzees and humans. They're obviously different, but they also have something in common.
Like set theory. If two different sets.
Yeah.
There is an intersection, right? Yeah. So this is the notion of inscription that is common to both mathematics and geography. Sorry, geometry and history. You see, both geometry and history, and with re. Right? This notion of inscription, I don't know if we use this word in our chapter. We're going to call this transdisciplinary. Transdisciplinary means a concept that cuts across disciplines. So there is an abstract concept of inscription that cuts across disciplinary boundaries, and there are very specific concepts, versions of that transdisciplinary version, one for history, one for geography, two different. That we agree. There is a difference, but there is also a unity. Okay? There is unity, there is also diversity, just like chimpanzees and humans. So we also have to figure out what that common thing is. Okay? I'm going to leave you with this. This is your homework or whatever, your lunch work or your tea break work, to figure out this one, and this one. For now, I'm going to focus on the math inscription. So the question that I'm asking you is, so this is inscription M and circumscription M, meaning math. Are they inverses of each other? Can we say if A circumscribes B, if you agree that, right, they are inverses, then the question that I have to ask is, granted that shape B is inscribed in A, if you agree that this is so, then of course it follows that A circumscribes B. If that is the case, then we can ask if this definition works.
So we have to replace vertices.
Why?
Because
In this
circle
case,
is having
it's
a
a
circle.
circle is
So?
A circle does not have
A circle does not have vertices.
Actually, all points in circle are vertices. You could say that.
Yeah.
therefore
But
infinite
then
vertices.
all the points are not touching
exactly.
the
Yeah.
perimeter.
You can break a point into many different points. Point is like infinite concept. You can break एक point into two.
Okay. Quite often when we have these discussions in the spoken mode, we forget what the propositions are. So I want to draw attention to an important statement that you are making, namely, a circle does not have vertices. Everybody agree? Does a circle have vertices? Yes or no? Anybody who thinks circles may have vertices? Hold on, yeah.
I think you could also say it in a way that all points in a circle are vertices because a circle is an infinite-sided polygon. So you could also say that all points are vertices.
Okay, this is,
They're all.
I'm getting out of my depth. I told you guys I'm not a mathematician. I'm trying to learn what this word circumscription means. Now somebody is telling me that every point in a circle is a vertex. So you have to tell me what a vertex is. What is a vertex?
Vertex is where the
Two lines meet.
Point where two lines meet. So I draw a line AD, and then I draw a line C, BC. Is this a vertex?
they meet at
And
a non-straight angle.
non-collinear point.
Non-collinear. Or meet at an angle not a straight angle.
Alright, this is going too far. I mean, I'm completely confused now.
No, so you start making a circle, so you start from this point and wherever the point meets, that is the vertex.
Okay, so Vagish is, okay, you have to watch out, okay? Anything that Vagish says is going to land you in trouble. Alright, Vagish is saying, you start something like this and go on, and then you come back, that is a vertex.
There is exactly
There is
one
only
vertex.
one vertex.
No.
But you can start anywhere else.
Start anywhere.
Yeah.
Ah, okay. So if you start here, you come back here, so you're saying, that is what you are saying, right? A circle has infinite vertices. Okay, you haven't defined the vertex yet, but suppose I accept. Suppose I accept without questioning that a circle has infinite vertices. This was possibly what Nishchay was also trying to suggest. A circle has infinite vertices. Okay, I don't fully understand what it means because you haven't defined vertex. Suppose I accept that. What is the consequence to this? Is it a case of circumscription?
No.
So
Right.
According to the definition.
So there is a vertex here and that doesn't lie on this. Okay, so what do you want to do?
Change the
Change
redefine.
Change, redefine this, change the definition, or change the judgment? You landed in trouble because you said this is circumscription.
It is.
Of course, if you say this is not circumscription, no problem.
But it is.
But it is.
It is. Everybody says it is. Okay?
She does not.
Sure.
So,
There's a square.
okay. Then you're saying that this is not a case of circumscription because this is not a circle.
It's not a circle.
So implicit in your statement is A circumscribes B only if A is a circle.
Yes. So you mean.
So you have to change your definition,
Yes,
right? Either way you have to change your definition, right?
I want to ask her something.
Yeah.
So what you mean is if I have a triangle and have a square passing through the vertices, that's not circumscription according to you?
Yes. Then what do you call that? Overlapping or whatever, I don't know.
It's
But
not overlapping.
overlapping.
It's not overlap.
It's not totally overlapping. Like,
But it's not
Circumscription.
circumscription.
So,
Come on.
what, I have some problem.
One side.
Wait. I didn't understand what Chaitali said about the squares and rectangles and so on. Can you draw?
So,
Can you draw pictures?
She's already ready with one.
yeah. Actually, three.
Okay. And I suppose I have a triangle and I have a rectangle which passes through the vertices. So this is not circumscription or inscription.
This is not.
This is what she says.
Yes.
According to her definition.
According to her, it is not. Is that?
Yes.
Then what do
Does
you
that make
call
sense?
it then? It's
What?
not overlapping.
In your language.
Yeah.
Yeah, but it's not even circumscribing.
Then what
This
is
is
the
not
rest of-
circumscribing and this is not inscribing. So-
Inscribing, I'm not sure, but it's not circumscribing.
Okay.
Inscribe because it's
When you have two words
Inscribe, then it has to be circumscription.
and it is
Yeah, of course. That's the point.
Are we agreed that inscription and circumscription
Are
occur
they-
simultaneously?
Yeah,
Are we
yes.
agreed on that?
she's not.
Are you not?
No, she doesn't say, she doesn't think that inscription is the inverse of circumscription.
Okay.
maybe
That's the whole point.
That's the point of the
That yeah. When we disagree on terminology, okay? When we disagree on terminology, then we have to deal with what the strategy that I use is to say she has one meaning for the word circumscription and you have another meaning for circumscription. When that happens, we use another word. Whatever. Does it matter? Because we are not interested in terminology. We are interested in the concept. And now we are going to say shape A here, alpha tribes shape B. And here again shape A, alpha tribes shape B. She can't object. Right? Because she has never heard this word alpha tribe. Okay, now if all of us agree that in both cases shape A, alpha tribes shape B, what is alpha tribe? Now let us define alpha tribe.
It means
Lunchtime.
we'll think over it.
yeah.
Yeah.
We'll think over
We'll
it.
think over it.
This is the best way to have indigestion.